Good morning, everyone, or afternoon, evening. Let's take a look at your Chapter 7 review for your test and run through a bunch of problems here that you can see on your exam. So the first one here says, write the equation to a polynomial with zeros at 6 and -7, and you let a equal 1. So when we're seeing this, what we're taking a look at, eraser, gotta get to the pen here, is when we talk about zeros, we're talking about x equals 6 and x equals -7. We want to write it in this form, y equals a, x minus the first root, x minus the second root. So we got to get it in these factors. So what you need to do is just move the numbers to the other side by doing its inverse operation. So here I'm going to minus 6. So x minus 6 equals 0. Here I'm going to add 7. So I get x plus 7 equals 0. So now I have the two factors. And what's nice is they tell you that a is 1. So we just know that this value here is 1. So we don't need to write it. Anything times 1 is itself. So we have x minus 6 times the quantity x plus 7. We have the first one done. Second one says write an equation to a polynomial with zeros at 3 and -4, which goes through this particular point, 552.2. So on this one we need to find a. So we're still using this formula up here. So we first start with the zeros. So we say x equals 3, x equals -4. So when I do the inverse operations, subtract 3, x minus 3 equals 0. Add 4, x plus 4 equals 0. Sorry, I forgot the 0 here. So I can start with my equation looking like this. Y equals a, x minus 3 times x plus 4. However, I still need to find a. So this is where this point comes into play. Here's my x value. Here's my y value. So when x is 5 in the equation, my y value equals 52.2. So I'm going to replace the y with 52.2. I'm still looking for a. My x value is 5. So I'm going 5 minus 3, and then 5 plus 4. So now 52.2 equals a times 2 times 9. So 52.2 a times 18. So now I just have to divide both sides by 18. And when I do, I believe a ends up being 2.9. I'm just going to check that real quick here. 52.2 divided by 18. See that on the calculator real quick. Sure enough, it is 2.9. So there's my a. So my final equation, y equals 2.9, x minus 3, x plus 4. Moving right along. Number 3. Number 3, it says solve by factoring. This is where you're going to use ZPP, zero product property. So I'm looking here at what are factors of -24 that add up to -5. So x and x. So if I can't think of them right away, I go 124, 212, 3, 8, 4, 6. Which pair differs by 5? Well, that's 3 and 8. Since I need -5, the larger one, 8, has to be negative. So I get x minus 8, x plus 3 equals 0. So now, set each of them equal to 0. So I get x equals 8, x equals -3. I apologize, I didn't actually show how I got those, but here I would just be adding 8 to both sides. So I get x equals 8, and here I was subtracting 3 from both sides. X equals -3. One of the things you can always do when getting these answers is check them. So if I just plug in, and I'll just check 8 here, 64. So 8 squared is 64. 5 times 8 is 40. Minus 24, so 64 minus 40 is 24, minus 24 is 0. If I try -3, I get 9, then this becomes plus 15 minus 24. 9 plus 15 is 24. 24 minus 24 is 0. I know my answers are correct. All right, moving along to number 2. Here we only have 2 terms. They have something in common. They share a 4 and they share an x. When I pull both of those out, I'm just left with x minus 3. So now I can set each of those factors equal to 0. 4x equals 0. X minus 3 equals 0. So now divide by 4. X still stays 0. And then when I add 3, x becomes 3. I can check both of those. 0, 0. Well, anything times 0 is 0. Minus 0. That's 0. If I check 3, 3 squared is 9. 9 times 8 is 72. Okay. And then when I try, whoa, wait a second here. Oh, I'm glad well, how would I? That's not working. What did Mr. Bartz do wrong? Oh, Mr. Bartz, see, this is why it's always good to check, because this answer is not correct. Because when I factored out the 4, there should have been a 2 there. So that should have been 2x minus 3. See? See how checking even saves Mr. Bartz. So 2x minus 3 equals 0. So I add 3 to both sides. So 2x equals 3. Divide both sides by 2. X equals 1.5. Woo! So if I take 1.5 and square it, it's 2.25 times 8, I believe, is, let's see, 16, I believe is 18. 12 times 1.5 is 18. 18 minus 18. Oh, good save. See, that one just saved me a point on the test. All right, number 4. You're asked to solve these values that are in vertex form. So this one, you might have some radical answers. So here we start off by adding 11 to both sides. So we have x minus 6 quantity squared equals 11. Then to undo a square, square root. Don't forget the plus minus. So now I have x minus 6 equals plus or minus the square root of 11. We still want to add 6 to both sides. So x equals 6 plus or minus the square root of 11. This one you don't have to simplify any further because the square root of 11 doesn't simplify. On B, same process, just a little more arithmetic involved. Subtract 12 on both sides. So 3x plus 2 quantity squared equals negative 12. Divide both sides by 3. So we get x plus 2 quantity squared equals negative 4. Now let's square root both sides. Plus minus crosses out. X plus 2 equals plus or minus the square root of negative 4. Now normally we'd say no solution, but now that we know about imaginary numbers, we're going to deal with those. So this is like saying the square root of negative 1 and the square root of 4. So now we have plus or minus 2i, because the square root of 4 is 2, square root of negative 1 is I. If I subtract 2 from both sides, we'll cross out and x will equal negative 2 plus or minus 2i. So we are going to allow complex solutions. And yes, you need to solve for those. I know that's usually a big question too. Do we have to do that? Absolutely. Number 5 says convert into vertex form. Vertex form, y equals a x minus h quantity squared plus k. So it needs to look like this. So you're just trying to get it to look like vertex form. You're not actually going to solve it. So remember with vertex form, what we do is we're just completing the square, but we're going to keep the numbers on the same side. So move the number over like it wasn't there. So now, complete the square. We always take half of the middle term. 2 squared is 4. So if I add 4, if I'm doing it to the same side, I have to subtract 4. Now the reason why I do that is this trinomial now will factor to be a quantity squared. factors of 4 that add to 4 are both 2 and 2. So this becomes x plus 2 quantity squared. I have minus 4 minus 1 is minus 5. Now it's in vertex form. Our vertex is at -2, -5. I know it didn't ask you to identify it, but it's good to know how to do it. All right, B. You do the same first step. 4x squared minus 48x. Move the number way over here, 154. Now this one has a number in front. So you have to factor out the 4 from both the 4x squared and the 48x. So when I take 4 out of there, I'm left with -12. Now I actually complete the square. Half of -12 is -6. -6 squared is 36. Now to balance the equation, I didn't add just 36 to the whole thing. I added 4 sets of 36. So 4 times 36 is 144. So I really added 144. So I have to subtract 144. So now I have y equals 4x minus 6 quantity squared, because factors of 36 that add to -12 are -6 and -6. -144 and 154 add to 10. And I have it in vertex form. All right, continuing on to page 2. Page 2 says sketch a graph of the parabola with a vertex at -3, -4. So I'm going to graph that point, -3, -4. There's my vertex. Zeros are at -1. So I'm at -1 and -5. Oh, whoops, I think I went over 6 right there. Yeah. Okay. Then write an equation of this graph in factored form, vertex form, and general form. So we're going to do all of them. The nice thing here is that A is 1. So in factored form, if my zeros are -1 and -5, I can say x equals -1, x equals -5. So when I move those over to the other side, add 1, add 1, add 5, add 5. Sorry, I'm doing them kind of at the same time here. So I have x plus 1 equals 0, x plus 5 equals 0. So in factored form, my equation is y equals, since a is 1, I don't have to worry about the number in front, x plus 1, x plus 5. For vertex form, that's pretty nice because you have the vertex -3, -4. We can go ahead and just write that in. Y equals, in fact, what I'll do is I'll change colors so you can see the difference. Y equals x, you do the opposite of x, so it becomes +3 quantity squared minus 4. Now for general form, you can choose, do either of these and FOIL it out or multiply it out and get it in general form. So if I take this one here and FOIL it out, I know I hit blue here. Try it again. So I'm going to FOIL. So I get x squared plus 5x plus 1x plus 5. So I combine like terms. My general form will be x squared plus 6x plus 5. Now I could have done this one too. If I did this one, I'd be going x plus 3, x plus 3 minus 4. So I go x squared plus 3x plus 3x plus 9. I still have that minus 4. 3x and 3x, notice how that matches the 6x. 9 minus 4 equals the positive 5. Have the x squared, they match up. It's a great way to check to make sure you wrote it correctly in vertex form. All right, continuing on. Number 7. Now we're going back to our 7.5 lessons where we're adding and subtracting and actually just doing all the different arithmetic for complex numbers. So remember, add or subtract the real parts. So our Operation here is subtraction. So 3 minus 4 is negative 1. 7i minus a minus 3i makes 10i. On the second one here, we actually have to FOIL, because 1 minus 7i quantity squared is like saying, if I get rid of the square, 1 minus 7i times 1 minus 7i. So I'm going to FOIL. 1 minus 7i minus 7i plus 49i squared. So 49i squared is the same thing as negative 49. Remember that I squared is the same thing as negative 1. So now when I combine like terms, 1 minus 49 is negative 48. Negative 7 is minus 14i. And we are good on B. C, we need to FOIL. Notice how they're conjugates. So when I go negative 6 and negative 6, I get 36. Negative 6 and 8i is negative 48i. Negative 8i and negative 6i is positive 48i. And then negative 8 and negative 8i multiplied to be minus 64i squared. Notice with conjugates, middles cross out. Negative 64i squared is actually positive 64. So 36 and 64 add up to 100. On the last one, we're just multiplying again, FOILing. So we get negative 12. Then we get plus 8i plus 24i, and then negative 16i squared. Negative 16i squared is really just positive 16. So 16 and 12 make 4. 8i, 24i add to 32i. We have it simplified. All right, number 8 says rationalize the denominator. So on this one, what you want to do is multiply the top and bottom by the conjugate of the denominator. So I'm multiplying the top and bottom by 2 plus I. So when I do that, I'm actually FOILing the top and FOILing the bottom. So when I FOIL the top here, I get 12 plus 6i plus 4i plus 2i squared. In the bottom, I get 4 plus 2i minus 2i minus I squared. So now when I start to simplify the top here, this becomes negative 2. So 12 minus 2 is 10. 6i and 4i make 10i. In the bottom, middle i's cross out. Negative I squared is actually 1. 4 plus 1 is 5. This one's really nice because 5 goes into both of them. So I'm left with 2 plus 2i. So this one simplifies where we have no fraction whatsoever. All right, on the second one, B, we have to multiply the top and bottom by the conjugate 3 plus 5i. 3 plus 5i. So when I FOIL the top, I have 24 plus 40i minus 3i minus 5i squared. In the bottom, I have 9 plus 15i minus 15i minus 25i squared. So now when I simplify the top, the last one becomes a plus 5. The negative 5i squared becomes plus 5. So 24 and 5 make 29. 40i minus 3i is minus 37i. All over, middles cross out. Negative 25i squared becomes 25. 9 plus 25 is 34. That one doesn't simplify because 29, 37, 34 do not have any factors in common. All right, graphing complex numbers. So remember, real number is on the x-axis, imaginary is on the y-axis. You can even see that it's labeled there for you. So the first one is 5, negative 3i. So there's my point, and I'm just going to put an A by it. B is just negative 3. Notice how there's no real part, so I don't go up or down. 1 plus I, here's 1 plus I, so there's C. And then with 4I, my real part is 0, so I'm just going up to here, and I am at D. All right, so there's page 2. Continuing on, page 3. Lots of problems on this review. Says, in number 5, change each equation into general form, if it's not already. Identify A, B, and C. Find the values of the discriminant, and tell what the value means. So on the first one, it's just not in order. So we're just going to rewrite the order of it, which is very important to help you identify the A, B, and C. So A is 5, B is -8, C is -6. Again, A is always the number in front of x squared, B is the number in front of x, and C is the constant. So now the discriminant, that's the b squared minus 4ac part. So in our case here, our discriminant is -8 squared minus 4 times 5 times -6. So in this case, I get 64 plus, because it's going to be -4 times 5 times -6, so that's, I believe, 120. So if I add those together, I have a discriminant of a positive 184. So that tells me that since it's positive, I have 2 solutions. All right, continuing on. Here it's in general form. A is 8, there is no B, and C is 2. So now when I do my discriminant, my b squared, I'm going 0 squared minus 4 times 8 times 2. So on this one, I'll have 0 minus, in this case, 64. So my discriminant is -64. So in this case, there are 0, I wish we would have said real solutions. So over here, this is 2 real solutions. We actually do have solutions, they're just going to be imaginary or complex solutions. All right, the next one. Nice, it's already in general form, so this will save us a, oh, no, it's not, I lied. So 4x squared minus 4x plus 1 equals 0. It almost got me. A is 4, B is -4, C is 1. So to do our discriminant, I'm going -4 squared minus 4 times 4 times 1. Well, that's 16 minus 16, which is 0. When the discriminant is 0, you only have 1 solution. Okay. On the last one, we'll have 3x squared plus 5x plus 16 equals 10. So I just reordered these where they're in general form, but it's not equal to 0, so I still have to subtract 10. So I get 3x squared plus 5x plus 6 equals 0. So I have 3, 5, and 6. So when I do the discriminant here, I'm going 5 squared minus 4 times 3 times 6. So I get 25. 4 times 3 times 6 is minus 72. 25 minus 72 is -47. So this has no real solutions. We're going to have 2 complex solutions. So now, for number 10, it says for each problem in 9, use the quadratic formula to find the solutions. So quadratic formula, x equals -b plus or minus the square root, b squared minus 4ac all over 2a. Now the nice part is you've actually done this part under the radical in the top part. So I'm going to save myself some time and some steps here in these problems a little bit. So on the first one, I know the discriminant was 184. So as I write this, I'm going to have x equals, I got to grab the opposite of b. So my b was -8 and my a was 5. So b was -8 and a was 5. Just to note that, because I'm going to do the opposite of b, so I get 8 plus or minus the square root. I've already done it, which was what, 184? You double check, 184. Okay. All over 2 times 8, or sorry, 2 times 5, since that's a. Now 184, does 184 have a perfect square in it? It does. 4 goes in there. I just need to figure out how many times 4 goes in there. So on my calculator, just quick 184 divided by 4 ends up being 46. 46 is a prime number, so, or I'm sorry, I shouldn't say prime because 2 goes in there 23 times, but neither of those are perfect squares. So now I could rewrite this as 8 plus or minus 2 square roots of 46 over 10. Now they all have a factor of 2 in common, so I have 4 plus or minus the square root of 23 over 5. All right, B. Now with B, if we take a look here, our A was 8, B was 0. Okay, so this one only had no real solutions. So, sorry, A, B, C. B I remember was 0. I think it was 8 and 2, but I'm just going to double check. That's what makes these a little bit harder. I got to go back and forth. So now, when we plug it into our quadratic formula, we have negative 0, plus or minus. This was negative 64, all over 2 times 8. Notice how the 0 is going to cancel out, so I'm now left with x equals, well, negative 64 is like negative 1 and 64. Well, the square root of 64 is 8. So I have 8i over 2 times 8 is 16. Don't forget the plus and minus. Well, 8 over 16, that reduces, so that plus or minus I over 2. C. So C, the discriminant was 0. Let me just move this up. So it was 4, negative 4, and 1. So we had 4, negative 4, and 1 as my A, B, C. So, again, it was x equals, will now be positive 4 plus or minus. My discriminant was 0 all over 2 times 4. This one's really nice because there's only one solution. That's gone. I'm left with 4 over 8, or x just equals 1/2. So that one went nice and quick. Love it when it's like that. On the last one, this one's not going to take too long either. A is 3, B is 5, and C was 6. Just want to double check that. And my discriminant was negative 47. So x equals negative 5 plus or minus the square root of negative 47 all over 2 times 3. Well, square root of 47, that's just negative 1 and 47. Nothing I can do with that 47. So I'm left with x equals negative 5 plus or minus I square roots of 47. 2 times 3 is 6. 6 doesn't go into either of those. So we are done. And done with page 3. All right, last page of our notes, the long division. So it says divide using long division, solve the resulting polynomials, and list all the zeros. So the first thing we want to do is the long division part. So we ask ourselves, how many x's go into x cubed? Well, x squareds. X times x squared gives me x cubed. 8 times x squared is 8x squared. So remember with long division, once we get how many goes in, we subtract. That should be 0. 7 minus 8, you got to watch your signs, minus 1x squared. Bring down the next term, negative 20x. So now I ask myself, how many x's go into negative 1x squared? Well, that's just negative 1x. So I get, when I do the multiplication, I have negative 1x squared. Negative 1 times 8 is negative 8x. Now remember, we're doing subtraction. So you could always do this, change it to addition, but then you got to change those to add, and then we add. So that's 0, negative 20 plus 8, negative 12x. Bring down the minus 96. Do it again. Ask yourself, what do I have to multiply x to get negative 12x? Well, we multiply by negative 12. So when I do that multiplication, I get negative 12x minus 96. Notice how, again, when we're subtracting like terms, 0, 0, and we have it. So right now, we have it as x plus 8 x squared minus 1x minus 12. We could say it equals 0 since we're trying to find the zeros. Well, let's continue to factor. So factors of negative 12 that add to negative 1 are negative 4 and positive 3. So now I can use zero product property, set them all equal to 0, and I can solve. So I get, subtract 8 here, x equals negative 8, add 4 here, x equals 4, subtract 3 here, and x equals negative 3. And we got our 3 zeros. All right, B says using synthetic division, solve the resulting polynomial and list all of your original zeros. Well, we know that this is a factor, so we know we can get a 0 there, so remember we do the opposite. So I go 5. Then I write all the numbers across of the coefficients. So 9, negative 45, 4, and negative 20. Draw a line. You always bring the first term down. So I bring down a 9. Multiply. 5 times 9 is 45. Add. I get 0. 5 times 0 is 0. When I add, I get 4. When I multiply, I get 20. When I add, I get 0. So what this tells me is that I have 9x squared, okay, plus 0x's minus 4 is my resulting last polynomial. Because again, these are my squareds, these are my x's, these are my constants. So right now I have x minus 5 times 9x squared minus 4 equals 0. Now you might be going, oh my goodness, how do we factor this? Well, no, it's a difference of perfect squares. We get 3x and 3x plus 2 minus 2. So now I set each of those equal to 0. And solve. So here I'm just going to add 5. So x equals 5 is a 0. Crosses out. So here I'm going to subtract 2. 3x equals negative 2. Divide by 3. X equals negative 2/3 is a 0. And then on the last one, I'm going to add 2. 3x equals positive 2. Divide by 3. X equals positive 2/3. And I have my solution. Okay? All right, C says using synthetic division, determine if negative 3 is a root of the function. So we just put negative 3 outside here. We just write the coefficients 1, 4, 3, negative 12. If it is a root, this should end in 0. So again, bring down the 1. Multiply. Add. Multiply. Add. Multiply. Not 0. Not a root. On the last one, just again, more practice with long division here. So, we're going to see how many x plus 5s go into 3x squared plus 10x plus 25. So I ask myself, how many x's will make 3x squared? Well, it's going to be 3x. So I get 3x squared, negative 5 times 3x is negative 15x. Remember, we're subtracting, so this becomes 0. Negative 10 minus a minus 15, that becomes positive, and you're left with 5x. Bring down the minus 25 and do it again. So x times 5 is 5x. 5 times negative 5 is minus 25. Notice how these add to 0. So I get x minus 5 times 3x plus 5. And I believe that's all you had to do on that one. Didn't ask you to find the 0, so you can just stop right there. All right, this ends your review packet. Good luck on your test.